Analyzing Subnet Mask. And today we are reading the fundamentals of Subnet Mask, and we will go over, do I know this already? So we do know that in binary numbers, zeros and ones, and the 0 is an off and the 1 is an on. And this is what we discussed yesterday. So today we will do a reading on the analyzing of subnet mask. And we are reading from Wendell Odom, and this is volume 2, chapter 13, analyzing subnet mask. And this is the network fundamentals. And I will begin to read. The subnet mask used in one or many subnets in an IP inter-network says a lot about the intent number design. First, the mask divides addresses into two parts, prefix and host. With the host part defining the size of the subnet, then the class A, B, or C, which is what we will discuss tomorrow, further divides the structure of addresses in a subnet, breaking the prefix part into the network and subnet. The subnet mask holds the key to understanding several important subnetting design points. However, to analyze a subnet mask, you first need some basic math skills with mask. The math converts mask between the three different formats used to represent a mask, which is what we discussed yesterday: binary, dotted decimal notation, prefix, also called classless interdomain routing, CIDR. And this chapter has two major sections. The first focuses on the mask formats and the math used to convert between the three formats. The second section explains how to take an IP address and its subnet mask and analyze those values. In particular, it shows how to determine the address and its subnet mask. And then we will go over, do I know this already? Chapter, which is chapter 13, analyzing subnet mask. It has 1 through 7. And we will go over this after we read. So let's start reading. This section describes how to connect between different formats for the subnet mask. You can then use these processes when you practice if you already know how to convert from one format to the other. Go ahead and move to this section, practice converting subnet mask, later in this chapter. 3 mask format. Subnet mask can be written as 32-bit binary numbers, but not just any binary numbers. In particular, the binary subnet mask must follow these rules. The value must not interfere The value must not interleave ones and zeros. If ones exist, they are on the left. If zeros exist, they are on the right. For example, the following values would be illegal. The first is illegal because the value interleaves zeros and ones, and the second is illegal because it lists zeros on the left and ones on the right. And this is the example. As the rule stated, the value must not interleave ones and zeros. If ones exist, they're on the left. So that's why that's not correct, because as you can see, the ones are not on the left. Zeros are on the left. And if zeros exist, they're on the right. So that's not right. The following two binary values meet the requirements in that they all have ones on the left, followed by all zeros, with no interleaving of ones and zeros. Two alternative subnet mask formats exist so that we humans do not have to work with 32 binary numbers. One format, dotted decimal notations, DDN, converts each set of 8 bits into the decimal equivalent. For example, the two previous binary masks would convert to the following DDN subnet mask because binary ones converts to decimal 255 and binary zeros converts to decimal 0. And as you can see, that's the 32-bit. That's one octet. 1 1 1 1 1 1 1 1 1 1 1. So there's 8 there. That's the first octet. And that converts to 255 because they're all ones. And binary zeros, they're all zeros, converts to decimal 0. Although the DDN format has been around since the beginning of IPv4 addressing, the third mask format was added later in the early 1990s, the prefix format. This format takes advantage of the rule that the subnet mask starts with some number of ones. And then the rest of the digits are zeros. Prefix format lists a slash, // followed by the number of binary ones in the binary mask. Using the same two examples as earlier in this section, the prefix format equivalent masks are as follows: /8 /24. And they're using this example. There is 32 bits. Note that although the terms prefix or prefix mask can be used, the terms CIDR mask or /mask can also be used. The newer prefix style mask was created around the same time as the classless interdomain routing CIDR specification back to the early 1990s. And the acronym CIDR grew to be used for anything related to CIDR, including prefix style mask. In addition, the term /mask is sometimes used because the value includes a slash mark, as you can see, slash. You need to get comfortable working with masks in different formats. The rest of this section examines how to convert between the three formats. So now we will go into converting between binary and prefix masks. Converting between binary and prefix masks should be relatively intuitive after you know that the prefix value is simply the number of binary ones in the binary mask. For the sake of completeness, the processes to convert in each direction are binary to prefix, count the number of binary ones in the binary mask and write the total in decimal after a 1. Prefix to binary, write P binary ones, where P is the prefix, P is the prefix value, followed by as many binary zeros as required to create a 32-bit number. Tables 13-2 and 13-3 show some examples. 13-2 and 13-3. Examples, conversion to binary to prefix. So you can see that each one has 32 bits. And if you look closely, that's the binary mask is the first column, the logic is the second column, and the prefix mask is the last column. So if you count 8 plus 8 plus 2 equal 18 binary ones, then you get 18/18. The second one is count 8 plus 8 plus 8 plus 4, 28 binary ones, you get 28/28. You count that, the third row, count 8 plus 5 equal 13 ones/13. Table 13-3, example conversions, prefix to binary. /18, write 18 ones, then 14 zeros, total 32. As you can see in the binary mask, the last row, 18 ones, 14 zeros, total 32. Prefix max, second row, /28, write 28 ones, then 4 zeros, total 32. Third row, /13, write 13 ones, then 19 zeros, total 32. Now we will go to, do I know this already? What we just went over is number 2 and number 3. Number 2 states, which of the following answers list the prefix CIDR format equivalent of 255.255.254.0? So as you know, it's 32 bits. As you can see, minus 1 at that 255, then 8 plus 1 is 9. So it's going to be 32 minus 9 is 23. Number 3, which of the following answers lines List the dotted decimal notation DDN equivalent of /30. The answer will be B, /30, the same, 255.255.255.252. So we know that there is 32 bits and that 2 All right. Thank you for watching, and I'll see you tomorrow. Wish you well.